This is the video on build the next Simplex Tableau. Over here on the left we have the beginning of the routine, and on the right we have the rest of the routine. It starts out with the instruction that says branch if equal the best row to 999 to BM. We know that the best row will only be equal to that high value if it never found the best row, so it goes to BM and everything's over. But if it did find the best row, it sets P equal to the best row and then multiplies P by the max columns, which is how many columns is in a row. So when it does this, then it has the offset to the transition row. And here it saves it in row index best. It saves this value of P, which points to the beginning of the transition row. Then it adds the best column to that value. Now we're not only on the transition row, but we are at what we call the pivot point, the intersection of the best row and the best column, and it saves that value at matrix plus that P in pivot value. Then it sets J equal to the best column. Alright, so it's going to work on that column. Set H to 0. And then it says for I of 0, and we'll go down here, it says next I part count 1. It starts at 0, so it's going around more than just the part count. It's also going to go to the margin row. Well, the next thing it says, if I is equal to the best row, go to BH. Down here is BH, and we're just going to add the number of values in, well, the number of columns to H and the number of columns to J. So that places them at the next row. But that happens if we're on the best row, because the best row is not to be changed this way. Well, the next one says branch if equal matrix plus J is equal to 0. Well, that's in the best column. Well, the best column is supposed to be 0 in those positions, so no operation has to take place. So we can go right to BH again. That particular row does not have to be changed because it has a 0 in the position already. And if it doesn't, though, it sets factor equal to matrix plus that J and divides its floating point, that factor, with the pivot value. That's the factor now that it's going to have to change every value in that row. Well, let's continue. It sets G to H, where we know that H is the beginning of that row. Then it sets L to the row index best. Remember up here, that's the row of the, well, that is the best row. That's what we call the transition row. So L is set to the offset of the beginning of that row, where G is the offset of the row we want to change. Then for K of 0, all the way to K equal to the quantity offset. So here it's not only going to change all the item ones and the slack ones, but also the quantity is going to be changed by the factor. So first it sets V equal to the value of matrix L. Well, that has to do with the transition row. Then it multiplies that by the factor that we calculated up here, and then it subtracts that from the value that's in that row. At that offset G, this is the row that's being changed. Then it adds 1 to G, adds 1 to L, because it's moving across. It's only increasing the offsets by 1 because it's moving through the columns in that row. All right, once that row is done, it's going to go check the next row. So H is changed by the number of columns in a row, and J is changed. And then it goes and it tries another row. Of course, if it's the best row, it doesn't do it. If there's already a 0 at the pivot point or the column in that particular row, it goes to BH and doesn't do anything. Otherwise, it does this change with the factor to the row. Well, next it comes down here and sets L equal the row index best. Again, that L is the offset to the transition row. The row that's going to be coming into the solution, you might say. Then for I equals 0, and again, all the way to the quantity value, it's going to divide the pivot value into every one of its values. So now the row that up here we didn't make any change to, now is the only row that we do make a change to, and that's the transition row. And I should point out here that the pivot value is one of the values in the transition row. It's the one in the best column. So what's going to happen when you get to that column, it's going to divide the pivot value into the pivot value and get a 1. All the other values in the column will be 0. Now we come over here. We're going to set I to the best row. Then we're going to set the row's item of I to the best column. The best column is what item it is that got brought in. But there's a row associated with it, with the best row in our case. And here we set the item to the best column. That's the item number involved. Then we're going to go around a loop here for all the values in our matrix and check to see if they're really small. First we set the V to their absolute value. Then we see if that's greater than or equal to this small value we know. You know, that's like 1/billionth or something. If it's greater than that, we go to BJ. If it's not, we set it to 0. These values can be very, very tiny, but yet they have significant values. But then when you check the exponent, you see that there's like 10 zeros in front of that value. Well, that's confusing when you see a listing of them. When the matrix is displayed, you say, oh, look at that big value, but then you find out that it's really a tiny value. So this is to set all those tiny values to 0, so it's easier to read the matrix. The next thing it does is it adds 1 to the tableau value, because this is another tableau, and it's keeping track of each tableau. Then it sets I equal to that tableau number. It's going to use I for an offset. Then it sets T to 0. It's going to make a total. Using T, sets L to 0, and H to the quantity offset. It's going to look at all the quantities, and down here it knows J is going to be set equal to the row's item. And here for K from 1, and down here next K for each part. Okay, so for every row, it's going to check to see what item is in that row, or associated with that row, let's say, and it's going to multiply it by, well, set the quantity to it, and then multiply it by its price and add it to T. The price of all the items that are not valuable, their price is 0. So it's only going to add up the items with a price, and then it's going to put that into T. And it goes around for each one of the rows, because it knows the item that's associated with each row. Well, after it does that, it rounds T. I'm not sure why it does that. It thinks T is going to be a really large number, so it rounds it. I don't know what would happen if you would put prices in that were fractions, tiny fractions, and then you rounded it and it ended up being 0. Well, we won't do that. All right, the next is it sets the tableau's incomes of I to that value of T, the tab's column of I to the best column, but then it has to add 1 to it because it wants to go 1, 2, 3 instead of 0, 1, 2. Same thing it does for the tab row. It sets it to the best row, but again it adds 1 to it, so it goes 1, 2, 3 instead of 0, 1, 2. Then the next thing it does is it saves that in its list of tableaus. It says multiply I by 500 and put this particular matrix at that offset in Tableau. That's how it can recall every tableau it did. It can recall every income for it and the column and row that were the best for it. Alright, this is the end of the video on Build the Next Simplex Tableau.